Hello everyone, welcome to Coders Camp. We are at 18th day of June LeetCode challenge, and the problem we are going to cover in this video is range sum query mutable. So we have to implement three methods, and the first method is numsArray, where we have to initialize our data structure, and the second method is void update, where the parameters passed are index and value to be updated in an integer array. And the third method is sum range, where they have given the left index and the right index, and we have to calculate the sum of the numbers from the array from the left index to the right index. So let's understand this problem with an example. So here is a given input, and we have first given an integer array nums with values 1, 2, 1, 3 and 5. So now we have a nums array with values 1, 3 and 5 at the index 0, 1 and 2. And comes the next method sum range from 0th index to 2nd index. So it is the sum of the given array. So it is going to be 9, and that is what we are going to add that to our output. And then comes the update method, where they have given at index 1 we have to update the value to 2. So instead of 3 we are going to update this value to 2, and now the sum is going to become 8. And comes finally the sum range method to call the sum from 0th index to 2nd index, and the sum is going to be 8. We are going to send that as our output, and the other methods update and num array are not going to have any output, so it is going to have null values. So how are we going to approach this? The straightforward approach is defining an array and updating the values directly at the particular index, and iterate every time and calculate the sum and return them. So here in the problem statement, the size of the array given as 3 into 10 power 4. So the straightforward approach is declaring an integer array with size 3 into 10 power 4 and updating the array's value with the given values. And whenever we call an update method, we are updating that particular index with that particular value. Same way for sum range, we are going to calculate the sum from the left to right and return the value. So this is gonna perfectly work, but the issue is it gonna time limit exceed for one scenario given in LeetCode out of the 15. So how do we optimize this? In this thing, update value is gonna take only constant time, and even declaring the array and assigning the value is gonna take constant time. But calculating the sum of a range is gonna take big O of n time, where n is nothing but the length or the difference between right and left. And for every sum range we have to iterate over the given array to calculate the sum, and that is what is going to make us take more time to execute this code. So we have to find some data structure or some method to calculate the sum of a range in optimal way. So the best solution would be either to use a segment tree or a Fenwick tree. So in this video we are going to see the solution of Fenwick tree, and let's dive in. I have already made a video on Fenwick tree in our channel exclusively with how Fenwick tree can be constructed and how can we calculate the prefix sum and etc. So you can check out that video to completely understand how Fenwick tree works. But here for this video, I'm not going to explain it in detail. Instead, we are going to have a very rough go through of how Fenwick tree works and how it is going to help us to perform this solution. So consider this array, it is a normal integer array. Consider this has been sent as our input. Fenwick tree or segment tree are generally used to calculate the prefix sum of an array. So here prefix sum is nothing but a sum of a range that is starting from 0th index to 3rd index and 0th index to 4th index and 0th index to nth index. It will be updating in a separate array, and it is easy for us to calculate the sum of a range using the prefix sum. So here, instead of calculating from the 0th index to the nth index, Fenwick tree helps us to calculate the prefix sum of certain range and store it in a data structure like tree-like structure, so that we can easily access the range of a sum instead of calculating right from the 0th index to nth index, just instead by calculating certain values at the certain ranges. So we are going to understand that how. Here we have represented the same integer array in the form of this. This is also nothing but an array, but I have represented in a different alignment in order to understand how this values has been calculated and stored. So here if you see at the very first index, the value is just 1. Directly we have saved it as that or that in the 0th index. And moving on to the second index, the value at the second index is nothing but the sum of 0 to range 1, that is 1 plus 7. At the third index, the sum is going to be the direct value stored in the third index, and in the fourth index it is going to be the sum of 0 to range 4. So it is nothing but 1 plus 7 plus 3. So again, so on, it has been stored everywhere in every index equal to what is given in the actual input array. So this will help us to calculate the sum of particular range. If suppose, I'll explain why we have aligned this value this way later. But now, if suppose we want to calculate the sum from the range 0 to 13, instead of calculating and iterating the complete array from 0 to 13, by using this array, that is the calculated and stored array, we can easily compute it, which is nothing but, if you want to calculate the sum of 13, let us first represent this number in the form of 2 power n. So how do we represent 13 as 2 power n? So it is going to be 2 power 3 plus 2 power 2 plus 2 power 0. So this actually going to be represented as 8 plus 4 plus 1. So what we are going to do is, we are going to pick the first 8 sum, and then the next 4 range sum, and then the next 1 sum. So the first 1 to 8 or 0 to 7 index sum is going to be at the 8 index, which is 29, plus the next 4 is going to be stored from 9 to 12 index, which is 10, and the next 1 index value is going to be stored at the 13th index, which is 4. So sum of 29 plus 10 plus 4 would actually give you the sum of 0 to 13. So how do we say that, and how do we store these values? So now we have to note two things to implement this Fenwick tree. The first thing is, at which positions which values should be present, and how do we know that we have to calculate the sum from this to this range and store this in this index. And the second thing is, how do we know at what position the values need to be calculated. So first we are going to see why we are aligning and adding these values this way, or how we are going to do that. So the thing is, we are going to represent the indexes in the form of binary. That is, 1 can be represented as 00001, 2 can be represented as 0010, and so on, and 9 can be represented as 1110. Sorry, 13 can be represented as 1110. So now, wherever there is a 1 at the last bit, which is nothing but this position, we are going to put the values as such. Same way, here there is a 1 at the last bit, and here there is a 1 at the last bit. Same way here, here, and here. So the places I have marked are having 1s at the very last bit. So in that case, we are going to update the values as such in their indexes in the given array. So which is nothing but having 1, and the index 3 is having 3, and this index is having 6 directly, and 1101 is having 4 directly. So we are not going to change these values. So next comes 1s at the second position. So wherever there is a 1 in second position, we are going to calculate the sum of range of previous two values. So this is nothing but the index 2 is going to hold the values of 0, 2, that is 1 plus 7. So same way, wherever there is a 1 in the second position, those numbers are going to have the sum of two ranges. So whichever I have marked in green are having 1s at the second position. So they all are going to have the sum of two ranges. That is, for example, here if you consider 0110, this is having the sum of range 5, 6. So which is nothing but 5 plus 8, 13. Same way, this index 1010 is having the sum of two range, which is nothing but 9, 10, where the values are 6 and 2. We had added that and stored as at 8. And same way, if we move on and considering the range or the index with 1s at the third position, and those are going to have the sum of first 4 bits or the first 4 indexes. That is from 0 to 4, the sum is 11, and that is going to be stored at this position. So this is how we're going to construct the new array or our Fenwick tree with this range of sums at different positions. So it is not going to have the direct values or the range of sum at every position it is going to have at specific positions only. So now how do we calculate a sum of a range using this? So let us take the same example of calculating the sum from the range 0 to position 13. How do we get that from our Fenwick tree? So now we're going to take the sum of index 13. So this is going to be represented as in 13. 13 can be represented as 1101. So we first have to take this value plus the next value must be added from its parent. And how do we identify its parent is flip the last one in the given binary number. So here the number is represented as 1101. If you flip the last one, so it is the last one. So if you flip it, then it is going to be 1100. So what is the value there in 1100 should be added. So 1100 is having 10. So we have to add 10 along with 4. So plus again right flip the rightmost one in the given binary number. So if you flip the rightmost bit, it is going to become 1000, and what is there in 1000 must also be added to this. So we are adding 29. So we have left with 1000. If you flip the rightmost one in this number, then it is going to become 0000. So we have nothing left to flip. So this is going to be, so 4 plus 10 plus 29 is actually going to give you the sum of the range 0 to 13. So how does it optimize our solution? So if we want to calculate the sum from the range 0 to 13, we have to iterate from 0 to 13, and that is going to take 13 iterations. So instead, we simply gonna take these three values and add it, and that is actually going to help us to finish it in only 3 iterations, or just picking the 3 values from the array directly in big O of one time and calculate the result. So all said and done, this Fenwick tree structure is nothing but another array where we are going to store the cumulative sum based on the idea we have seen in just another array, and take the value from the corresponding indexes and add them and return them. So here, as I said, we are going to store the values based on the bits of the indexes. So as I said, wherever it is there is a 1, it is going to directly store the values first, and wherever there is 1 at the second position, then it is going to calculate the value of 2 numbers, and wherever there is a third one, that is 1 at the third position, it is going to calculate the sum of first 4 values and store it in the array's index. So once all the values are added, we are going to take the range. If suppose we are getting the question as we have to find the sum from the range 6 to 10, then in that case we pick the binary number of 10, that is 1010, and we add what is the value there in the constructed Fenwick tree, which is 8, plus 1000 is its parent, and what is the value there in that index is going to be 29. So this is going to be the sum of the range 0 to 10 minus what is there in 0 to 5. So 5 is 0101 and its parent is going to be 0100. So we are going to calculate these, add these two values in the Fenwick tree, which is 11 plus 5. So we are going to subtract this value from this value, and that is what the sum of the range 6 to 10. So this is how it is going to work, and we missed one thing to discuss here, which is how do we find its parent programmatically. So we know manually that if you flip the rightmost one, then we're going to get its parent until it is going to become 0000. We are going to iterate it. So how do we feed it to the system programmatically? And here is the technique where we can feed to the system how to flip the rightmost one in the binary number. So we are first going to take the 2's complement of the given binary number and do an AND operation with the original binary number and subtract it from the original number. So for example, take 13. 13 can be represented as 1101. So manually, if you do a right flip, it is going to become 1100. Programmatically, we are going to do a 2's complement, and then once 2's complement is done, we are going to do a AND operation. So once AND operation is done, we are going to get a number. So from 13, if you subtract the original number, it is going to become 12. And if you convert 12 to a binary number, it is going to become 1100, which is actually the right flip of last one bit from 13. So this may look so complicated, but programmatically we are simply going to represent if n is the binary number, then n and minus n is going to perform this operation, which is nothing but 2's complement and an AND operation with the original number. So this is going to be the key to store the values in the Fenwick tree as well as to retrieve the values from the Fenwick tree. So hope you're understanding the solution. So let's go to the code now. So let's declare our data structures. I'm going to maintain a array tree to store our calculated Fenwick tree values, and an integer array num to store the normal values of the given array, and a variable size to get the size of an array. So let's initialize them. So here we have declared our tree alone to size plus 1 because our Fenwick tree is going to start from the index 1, that is 0001, so that we easily get the bitwise operations done. So we declared that alone size plus 1, and we are going to update the values of passed integer array nums to our initialized array directly, and we are going to construct our Fenwick tree in this data structure, in this constructor. So to construct a Fenwick tree, I'm going to write one more method, which is update tree. So where we pass the index and the value to add it to our tree. So we are going to call that update tree method here from our constructor for every value that we are inserting into our tree. So let's spend some time in writing the update tree, where this is going to construct our array tree with the calculated Fenwick tree values. So here we are going to iterate the index to one index next, because that is how our Fenwick tree is going to have its indexes, and we are going to update the tree with the value. But as we said, we are going to update certain values in certain cumulative sum. So we are going to iterate till our index is going to become less than size, and inside that while loop I'm going to update my values of cumulative sum. So it is going to add the cumulative sum of the values at indexes its parent. So this index is going to update it with its parent's index every time, and it is going to add the value at that particular index to our Fenwick tree index. So every time we update a new value in any particular index, it is going to calculate the cumulative sum of that particular approach we have seen and store it in our tree array. So yes, now we have constructed our Fenwick tree array by using this update tree method. Now goes to our update method. So this update method is going to update or add a new value to our Fenwick tree. So this is again going to call the same update tree method with the index and the value. So why value minus nums of I is, so we already have calculated the cumulative sum, so it is not simply going to update the value directly. Instead, it is just going to update the difference, and our actual array is going to have the actual value. So yes, now comes the sum range, where we are going to calculate the sum of a range. So first let's check whether they have asked only the index 0th value. Then in that case, simply return the sum which actually stored in our Fenwick tree. So to calculate the sum, we are going to add one more method, which is get sum. So this will help us to get the sum of our range from our Fenwick tree array, where we pass only the index, and it is this is the index of 0 to I, and whatever it may be, whether it's 0 to 10 or 0 to 6. So as I said, it is gonna iterate till all our bits are going to become 0, and every time it is gonna add the sum from the calculated Fenwick tree array, and every time it is gonna add its sum with the rest of its parent. So yes, this is going to loop until it calculates all the sum and return it. So this is going to return the sum. So if it is asked to calculate it from 0 to, sorry, if our left is equal to 0, then if our left is equal to 0, then 0 to the sum range is going to be simply get sum of. If not, we are going to return get sum of left minus get sum of, sorry, get sum of right minus left minus 1. So yes, it calculates this range from 0 to left minus 1 and from 0 to right and subtract it from each other. So yes, this is it. Let's run and try. Yes, let's submit. Yes, the solution is accepted and runs in 62 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.